Hello everyone, I am Aswani, Assistant Professor, Department of AIML at MLR Institute of Technology. Welcome back another session of Artificial Intelligence. In this session, we will going to learn about basics of Prolog. So the Prolog is a logic programming which is used especially for artificial intelligence to write the programs. Let's see the overview of this session. We'll see Prolog introduction part. And we'll see how to install and execute the Prolog programs using SWI interpreter. And we'll see the basic building blocks of the Prolog, that is facts, rules and queries. And we'll execute some examples. Let's see the introduction part. So Prolog is a logic programming log pro. Then it is called as Prolog. Prolog is a logic programming language. It has important role in artificial intelligence, especially it is designed for the artificial intelligence programming. Unlike many other programming languages, Prolog is intended primarily as declarative programming language. Means in C, C++, Java, if you take any programming language, in that will have some rules and syntaxes to write the program, we will use the functions and we'll call that functions to execute that particular program. But in this Prolog, we'll use the declarative programming language. We'll store the data into some knowledge base and we'll retrieve that data. Based upon that, we'll query to that SWI, means we'll query the machine and it will answer based upon the knowledge base what we have stored into that knowledge base. That is a declarative programming language. In Prolog, logic is expressed as relations called as facts and rules. So here it will be stored into the database, that is in the form of facts and rules. That is intentionally, conditionally, it will be true in the nature. Okay, so these are the important basic building blocks of Prolog. That is the knowledge base, it will play the vital role, and another one is facts, rules and queries. The first one is knowledge base. We'll see more about this knowledge base in the further sessions also. And in the previous sessions also, we have seen the knowledge representation, how it will represent the knowledge and where it will be stored. So the knowledge base, this is one of the fundamental part of the logic programming. Without this knowledge base, we can't run the program, so we can't write the program. So this is the essential part of the Prolog. So we'll see more in the next here facts, rules and queries. So the facts, these are the building blocks of logic programming. We'll get some detailed knowledge about facts and rules. We'll write the facts and we'll store into the knowledge base in the form of rules, and also see some kind of queries that will be used in logic programming. The user poses the query and the machine will search that query related answer into that knowledge base. If it is there, then it will be give the answer to that user. Let's see. So what is the facts? We can define facts as an explicit relationship between objects and properties these objects might have. So facts are unconditionally true in nature. Whatever we will write in the knowledge base, that will be unconditionally true in the nature. Suppose we have some facts. Tom is a cat. So the cat name is Tom, like that. And all these are the unconditionally true. There is no condition says that definitely if a equal to 2, then only it will be, means like that is some condition. For example, if you want to know the even number, then we will write if a modulus 2 equal to 0, then only it says that even number, otherwise it is odd number. There is no such type of condition. Here unconditionally in the nature these facts are true. So cat name is Tom, then it is true. Kunal loves to eat pasta, true. Hair color is black. Nawaz loves to play games and Pratyusha is lazy. These are some facts that is unconditionally true in the nature. All these facts are stored into the knowledge base, database. So these are some facts that are unconditionally true. These are actually statements that we have to consider as true. Okay, not only this one, like that we can write a girl named Rani boy Ravi. Like that we can write any statement as a true in the nature, and we can store it into the database. Okay, let's see how it will be work in the diagrammatically. If it is a functional programming, there is a main function will be there. Inside main function we'll write some statements, and we'll write some methods, will invoke that methods, then it will goes to that method to execute. For example, procedure 1, then it will goes to that method when we invoke, and it will execute that procedure 1. That is a functional programming. Whereas in the logical programming, how it will work, let's see. There is a machine, and the user will ask the machine, and machine will give the answer. Before that, the machine will maintain a knowledge base, the database. In that database, it will have this domain specific knowledge that is collected from the experts, domain specific experts, or articles, or newspapers, or journals, and the data will be engineered, means it will be corrected by the experts by taking feedback from them, and it will be stored into the database. Whenever the user poses a query, the machine will verify in the knowledge base, and it will search for that question, and it will give the answer. In this way, the logical programming will be executed. Whereas functional programming, we will write the set of rules and syntaxes, and we'll write some functions, and whenever we will invoke, it will execute that particular task. Let's see the some of the guidelines to write the facts. So names of properties or relationship begin with the lowercase letters. So we'll start with cat, Tom, otherwise lazy. The relationship first, followed by the objects. Pratyusha, lazy, like this. So names of properties, relationships begin with the lowercase letters. The relationship name appears the first term. So Pratyusha is lazy. So lazy is the relationship that will comes to the first. Objects appear as comma separated. For example, Navas loves to play games. Then how we will write? First it has to come the relationship. So loves to play, loves to play. This is the relation. Then the objects that are separated with the comma. Navas games. So this is the rule how we have to write. First it should be relationship followed by the objects, that objects are separated with the comma. So how we will read this fact? Navas loves to play games. So in such a way, based upon the scenario, the rules will be changes. Objects appear as comma separated argument with parenthesis. Within the parenthesis, these objects, Navas is an object, games is an object. Those two are separated with the comma. A period must end a fact. So after writing this data, we should keep a period. A period must end a fact. Objects also begin with the lowercase letters. So here Navas games also begin with the lowercase letters. They also can begin with the digits like 1, 2, 3 means a phone number. If you want to write a phone number, then we can write like this. A phone number is 1, 2, 3, 4. Like that we can write. And can be string of characters enclosed in codes. Like for example, color, pen, ink color, red, like that. Phone number is also called a predicate or class. So phone number, Agniba, and this is the phone number. So these are the rules how to write the facts. The first one is names can start with the lowercase. Names or relationship starts with the lowercase letters, and objects are separated with the comma, and the fact must and should end with the period or full stop, and objects appear as comma separated. These are guidelines to write the facts. Let's see the syntax. The syntax for fact is relation is first, followed by object 1, object 2, and so we can write a number of objects and enclosed within the parenthesis and end with the period. For example, following is an example of the above concept, whatever we have discussed here. Tom is a cat. How we will write? First, it should appear the relation, that is cat of Tom. Next, Kunal loves to eat pasta. Loves to eat relation, Kunal comma pasta. Kunal object, pasta object. Hair is black. So, color of color, hair black. How we will read? Hair of color black. Next, Nawaz loves to play games. Like that we can write. Otherwise, we can write games inside the parenthesis also. Pratyusha is lazy. Like that we have to write and store within the database. Let's see how we will store and how we will query the query and retrieve the answer. Let's download and install the SWI interpreter. Go to Google Chrome. In the Google, type SWI Prolog. Download the first one, SWI Prolog. This is the icon of SWI Prolog. Open it, and here check the compatibility of your system configuration 64-bit. Just click on this, then it will be download in your downloads. Okay, open the downloads. SWIPL 9.3.25 64 compatibility. Just double click on this extension file, then it will start installing. So just we need to select accept the terms and conditions by clicking the checkbox. After that next, and it will be installed in your default C drive. If you want to create a desktop icon, you can create by clicking the checkbox, then it will be created on the desktop like that SWI Prolog icon. If you want to write a program or if you want to queries, then you need to open the SWI Prolog interpreter. Will be look like this, the question mark and followed hyphen. So first, if you want to write the program, first we need to store the data into the knowledge base or a database. Whatever we have seen, Tom is a cat, name is a Tom, and Pratyusha is a lazy, love to eat pasta. Like that, whatever data is there, that data need to be stored into the database or knowledge base. To store the data, first we need to open, or directly we can write into the notepad, and the extension should be .pl, and all these files are stored into the documents and Prolog folder that we will see. So first open file, click on file, click on new, then it will be open. Let's see where it is saving. This PC documents Prolog, that is where it will store, because already it is connected with this documents and Prolog. If you saved in anywhere else other than this location, then you have to load the that files into directly to the SWI Prolog. Otherwise it won't recognize those files, because this path is selected to this documents and Prolog folder. So writing first one, my first Prolog, and extension is .pl. Prolog files extension is .pl. So here this is the document, and directly also we can write inside the notepad and save it inside the documents and Prolog folder, and save it as a .pl extension. I'm just directly copying this. So each and every statement needs to end with the dot. That is what we have seen some guidelines. So cat, the relation, and Tom is a cat. Kunal loves to eat pasta. Like that we have to write and end with the period. After that compile or Control C and Control B we need to enter to save our data into the database. Then open SWI interpreter. Now we need to query the machine like cat of Tom, and it need to end with the period. If you are not keep a period, then what happens? It is keep on waiting unless we put a dot. Okay, true. Whenever we have write cat of Tom, it will goes to the my first PL file and it will search for the data cat of Tom. Yes, it is cat of Tom. Tom is a cat. Then it will return true. Otherwise, we'll write cat of puppy. And must and should end with the period. Enter. It is a false. Why? Because there is no such type of data in the database. Cat of puppy. First it will goes to that file and it will check for the cat. Yes, there is a cat and it will check for the object. Is there any puppy? Is there? There is no puppy in this database. Then it will return the false. Like lazy and with the period. Yes, true. Again it will goes to that file and check for the lazy Pratyusha. Yes, it is there. Then it will return the true. Otherwise it returns false. Either positive or negative information will be given. Okay. Let's continue. Next, the rules. Already we have seen the facts, how it will be stored, and these are unconditionally true in the nature. So the rules, we can define rule as an implicit relationship between objects. So facts are conditionally true. So when one associated condition is true, then the predicate is also true. Suppose we have some rules as given below. Lily is happy if she dances. Whenever Lily dances, then she felt happy. So there is a condition. So we can write the facts unconditionally true, or we can make them as conditionally true. Already we have seen the data, how we have to write and how we can retrieve the data. Next, Tom is hungry if he is searching for food. Whenever Tom is searching for food, then it is the Tom is hungry. Jack and Billy are friends if both of them love to play cricket. If they both are love to play cricket, then only they both are friends. Next, we'll go to play if school is closed and he is free. When he is free and the school is closed, then only he goes to play. So these are some rules that are conditionally true. So when the right hand side is true, automatically the left hand side is also true. Whenever he is searching for food, then automatically he is hungry. Let's see here the symbol, how we will write the data, that is colon and hyphen will be pronounced as if or is implied by, and also we will call it as a neck symbol. So LHS of this symbol, left hand side of this symbol is called the head and right hand side of this symbol is called as body. Here we can use the comma, which is known as conjunction, and can also use the semicolon, that is known as disjunction. Conjunction, comma, disjunction, semicolon. Let's see the syntax. Rule name followed by object 1, object 2 and a neck symbol. Facts. Whenever left side is true, automatically right side is also true. Suppose a clause is like P if Q and R. Let's see. Q and R. This one is a disjunction, semicolon. So this can be rewritten as P implied by Q or P implied R. Let's see the real-time examples. Example like happy Lily dances. When she is happy, when Lily dances. And here Tom hungry. When search for the food. Tom searches for food. Jack and Billy friends. When Jack and Billy loves the cricket. Next, Ryan go to play is true whenever he is close to school. Free Ryan, comma, means is closed, free, school is closed, and Ryan is free, then only go to play. Let's see how it will be executed. Before this, dances. Control C, Control B. Go to Sri interpreter. Right. Happy Lily. True. Next. Dances Lily. LI. Compile. LI. Happy Lily. Dances Lily. Dances Lily. Whenever she dances, then Lily is happy. Let's see. So, dances Lily. When Lily is dances, automatically the left hand side is also true. That is what we have seen in the next symbol. So, before that we need to write dances Lily, and we need to check whether the Lily is happy or not. Yes, she is happy. Let's check another one. Control C. Compile. Buffer. Okay. Control True. Then again check for Hungry Tom. Control C. Control V. Yes, true. Whenever the right hand side is true, automatically left hand side is also true. Okay. So in this way, we will use the conditional statement and rules to write the facts. Next, queries. Already we have queried also. We need to write the queries into the SWI interpreter. Then it will go to that particular PL file and it will check for that statement whether it is present. Then it return the positive. Otherwise, it return the negative or error. Queries are some questions on the relationships between objects and object properties. So questions can be anything as given. Is Tom a cat? Then we have to write cat of Tom. Then it will return true. If cat of puppy, then it return false because there is no such a type of statement in the database. Does Kunal loves to eat pasta? Is Lily happy? Yes, when she dances, she is happy. Will Ryan go to play? Yes, when he will go to play, when his school is closed and when he is free, then he will go to play. So these are the two conditions need to be true. Then only Ryan go to play is true. So according to these queries, logic programming language can find the answer and return them. Okay, let's see what is knowledge base. Already we have seen. As we know, there are three main components in logic programming, that is facts, rules and queries. These are also called as basic building blocks of Prolog programming. Among these three, if we collect the facts and rules as a whole, then that form a knowledge base. We need to write the facts in the form of rules. So we can say that the knowledge base is a collection of facts and rules. Let's see one example. Suppose we have some knowledge that Priya, Tiyasha and Jaya are three girls. Among them, Priya can cook. Let's try to write these facts. Girl Priya, girl Tiyasha, girl Jaya, cook Priya. Like this, we have to write into the database. So we'll write all this into the database in the .pl file and we'll post the query into the SWI Prolog. It will give the answer girl Priya true, girl Tiyasha true, girl Jaya true, girl Priya. Then it will give the false negative because we have not written girl Priya. When we have asked the question cook Priya, then it will return the true because we have written cook Priya. Okay, so in this session we have seen the basics of the Prolog programming, like what are the facts, what are the rules and queries, and how to install, download and install the Prolog, and what is the extension of the Prolog programming, how to execute the Prolog programming, how to write the facts and rules in the database. In the next session, we'll see the applications and representation and structure of the Prolog programming syntaxes. Okay, thank you.